All right, y'all, here we go, related rates. So this is basically implicit differentiation on geometric formulas that we're getting out of word problems. That's the big idea. It's all the things, all at once. Here we go. So, we use the idea of calculus is like the math of change, how things are changing, how they're related to each other. And we have the ideas of like increasing and decreasing or growing and shrinking. There's these are the words that we've been using. And if we think about our change as a function of time, like the position of where I am is a function of time, because right now I'm here, but in like 30 minutes I might be over there. So it's a function of time where I am. And we can have these quantities changing, and that's something that we can express mathematically. So if we're looking at the growth rate of someone named John, that is 3 inches per year, then John's d growing is a height, right? dh dt. So the change in the height of John versus the change in time is going to be 3 inches per year. If you haven't seen Rady the Math Cat, that is a really fun per vocabulary video. It's really fun. It's great. Alright, so my mutual fund is shrinking by 4 cents per day. So the amount of money that I have, so like D mutual fund or D money, DT, is shrinking, so that's negative, right? So it's going down by 4 cents per day, and we're going to be mathematicians about this and have 4 cents per day expressed in terms of like dollars, because that's how like numbers go. So cents per day is what is this? $3 per day. Now that we've converted it from cents into dollars, it's just that's how generally we think about money. But you know, it's up to you. Mutual funds, by the way, are good to start when you're young. So you know, if you are able to, even a little bit, totally helps. Okay. The radius of a circle is increasing by 4 feet per hour. What kind of a circle would be increasing by a radius of 4 feet per hour? Maybe like a pool of lava. Maybe like a wet spot from like a drip or a flood. Something like that. Radius of a circle. So dr, dt. And look, all of our changes are with respect to time, right? Is 4, and it's increasing, so it's positive 4 feet per hour. So what would the volume of a cone decreasing by 2 inches cubed per second? What would you write? Put a question here. So dV, volume, dt. Sometimes with V's I put a little tail on it. This is just so I don't confuse it with U's, because sometimes with U's I forget to put a tail on it. So this is just me trying to be clear, but sometimes it doesn't work. Sorry. It's a very physicsy thing. I don't know why I still do it. I haven't taken physics in a very long time. Decreasing to -2 inches cubed per second. Alright, so we wrote those mathematically. So if we know, and the key for related rates problems is to draw a picture, figure out what formula, what geometric formula or other relation kind of formula you're going to use, and then take your derivative with respect to time, because the rates that we're thinking about are in terms of time. So we have a rectangle that is 10 inches by 6 inches whose sides are changing. So here's my picture, rectangle, boom. 10 inches by 6 inches, but it says only label variable information. That is very helpful advice. So let's not do that. Let's do 10 length and let's do that. Length and width. Okay, so given the length is increasing at a rate of 2 inches per second, so d L dt is 2 inches per second. And the width is increasing, dw dt is increasing, so it's positive 3 inches per second. It's very important that we include units because that's what responsible mathematicians do. So how fast is the perimeter changing? So what is the formula that we need to use? Good question here. So the formula that we need to use is the perimeter is 2L plus 2W. Oh, sorry, that's down here. We're looking... Look, I sneezed into my shoulder. It's responsible. We're looking for dP dt, and the equation that we're using is P equals 2L plus 2W. I'm going to erase that so we clean that up. So we're looking for dP dt, and what's the units on this? Well, perimeter is measured in inches, so we're still looking at inches per second. All right. What if its length is increasing at 3 inches per second and its width is decreasing at 2 inches per second? So we still have length and width. We're given that dl dt is positive 3 inches per second and dw dt is negative 2 inches per second. Find how fast the area is changing. So we need to find dA dt. So what's the equation for what we need to deal with? Put a question here. So we have the area is length times width. So why don't we do these two real quick? So we have, for this one, let's go with the lava pen. We have the perimeter is 2L plus 2W. So dP dt, when we differentiate with respect to time, we get 2 times dl dt, the rate of change of the length, plus 2 times dw dt. And that makes sense. If the width is changing, and it is increasing at a rate of 3 inches per second, then if this width is changing, this width is also changing, so it's doubling. And same goes for the length. If the length is increasing on this side, that means that the length is increasing on this side of the rectangle, so it's doubled. So then we have dP dt is 2 times dl dt, which is 2, plus 2 times dw dt, which is 3. And then we just use good order operations, and we get, what, 4 plus 6? 4 plus 6 is 10 inches per second. So the perimeter is changing at 10 inches per second. What about our area for this other... What about the area for this other rectangle? So what do? Well, we have the area is length times width, so we need a product rule this, right? dA dt equals length times dw dt plus dl dt times w. And then what are L and W? Well, actually we're given that up here. 10 inches by 6 inches. So we have dA dt is equal to length, which is 10, times dw dt, which is negative 2, plus dl dt, which is 3, times the width, which is 6. So we have 10 times negative 2 is negative 20, plus 3 times 6 is 18. So we have negative 2 inches squared per second as our units. And let's make sure that those units make sense. So the units here are inches. The units here are inches per second. And the inches per second here. And that's inches. So if you multiply inches times inches per second, then you get inches squared per second, and those units are consistent, so we're happy, and so is your chemistry teacher. All right. So what do I have here? We have a right triangle that has sides 30 and 40 inches, and the sides are changing. This is nice, though. 30 and 40. It's really nice. This is a 3, 4, 5 triangle, then, right? The short side is increasing at 3 inches per second, and the long side is decreasing at 5 inches per second. So let's draw our triangle. It's a bad triangle. Okay, slightly better. Oh my gosh. Alright, so this is a right triangle. I'm sorry. Okay, so this is, let's call it A. Let's call this B. So A is the short side just because it's first. Okay, so we're given dA dt is increasing, so there's positive 3 inches per second. And dB dt is, the long side is decreasing, negative 5 inches per second. Please look up Rate of Math Cat. This is all the purrs that I'm giving. Okay, so we need to find the rate of change of the area of the triangle. So dA dt equals what? What equation are we going to use? Well, we have the area of a triangle is 1/2 AB, which is like the base times the height. Base is B, base. And then the height is A, which was poor choice, but that's okay. All right. Does like height and then hypotenuse, like, it's, yeah. I like A, B, and C. You could also use X and Y, like, I don't really care. So how do we find the rate of change of this area of our triangle? Well, dA dt is going to be equal to 1/2. And then we product rule, right? So I'm going to put parentheses because otherwise I'm going to forget. A dB dt plus B dA dt. And then we substitute. So we have 1/2. A in this case is 30. 30 times dB dt, which is negative 5, plus B, which is 40, times dA dt, which is 3. And then what do I get? This is the part where I really miss having a class, because you're all calculators for me, and I don't have to do it. Okay, so 1/2, 30 times negative 5 is negative 150, plus 40 times 3 is 120, and then what is that? 1/2 times negative 30, negative 15. What's the units on this? Pause. What's the units? The units are inches squared per second. How fast is the hypotenuse changing? So the hypotenuse, well, what equation do we need to use to figure out how fast the hypotenuse is changing? We have this A, we have this B, and we have this C. How do we figure out what those are connected with? Pause. Well, we know that A is 30, B is 40. We know that C is 50 just from 3, 4, 5 triangle. But we need to find how fast the hypotenuse is changing, so we need to find dC dt. So what equation do we need to use? Pythagorean theorem. Let's go. A squared plus B squared equals C squared. Nice. Okay, let's take our derivative. Derivative on the right and derivative on the left. So, sorry, this is bad. Okay, so power rule on C squared. That's 2C, and then chain rule on C, dC dt. Right? Because the hypotenuse is changing if the two legs are changing. And this equals, power rule on A is 2A, chain rule dA dt. Because the side length is changing. Plus 2B dB dt. So how fast is the hypotenuse changing? Well, actually, all these 2's can cancel out, right? Because we just divide everywhere by 2, so pew, pew, pew. We have C is 50, dC dt is A, which is 30, times dA dt, which was 3, plus b, which is 40, times dB dt, which is -5. So then we have, well, I'm just going to cancel out those zeros because that's not necessary. Just divide everything by 10, right? So then we have 5 dc dt equals 9 minus 20. So then we get dc dt equals, what's 9 minus 20? -11 over 5 inches per second. Alright, so let's look at a cylinder. So we have a right circular cylinder that has a height of 10 feet and a radius of 8 feet whose dimensions are changing. So we have the radius of our cylinder, dr dt, is 2 feet per minute. And the height, dh dt, is shrinking, -3 feet per minute. What's the rate of change of the volume of the cylinder? So we need dv dt, and wildly inconsistent with the v's, but that's okay. So the volume of a cylinder, there I did it again, is, what is it? Pi r squared h. So dv dt is going to be product rule with this pi times, because that's a scalar, right? Times 2r dr dth, because that's the derivative of r squared, plus r squared dh dt. Plug in what you know, figure it out. So what do you get? dv dt is pi 2 times r, no, r is 8, 2 times 8 times r is 2, dr dt is 2, h is 10, plus r squared, which is 8 squared, dh dt is -3, and then we just multiply that, and we figure it out. What is that? dv dt pi times, what is that? 320 minus 6. Oh my gosh. You do that. Alright. It's math. Okay, so we, what's the radius? If the radius is decreasing at 4 feet per minute and the height, dh dt, is positive 2 feet per minute, what's the rate of change of the surface area? Let's call this A, S dt. Surface area of a cylinder is pi r squared, and 2 of those, right, for the top and the bottom, plus 2 pi r h, which is the rectangle that's wrapping around. So that's the surface area. So ds dt is just, what, 4 pi r dr dt, because the radius is changing with respect to time, plus, and now we product rule, 2 pi times r dh dt, plus dr dt times h. Plug in what you know, figure it out. Alright. So the goal is to figure out what to do. First, draw a picture. Second, label stuff. Write down what you're given and figure out what you're trying to find. And then try to tie all of the things that you have written down together. Take your formula, take the derivative with respect to time, plug in what you know, figure it out, and find the units, make sure that your units match. That is the goal. Step 1, draw a picture. Step 2, write down what you know, differentiate with respect to time, plug in what you know, solve with algebra. Alright, so, oil tanker spill. This is a very good question. If we have an oil tanker that spills oil and spreads in a circular pattern whose radius increases at a rate of 50 feet per minute. So we have a circle. So we draw a picture. And you have this radius. dr dt is 50 feet per minute. How fast are the circumference and the area of the spill increasing when the radius of the spill is these two different times? So these two different measurements. So we need the circumference is 2 pi r, right? Circumference. And then the area is pi r squared. So when we differentiate with respect to time, dc dt, 2 pi dr dt. And for area, when we differentiate with respect to time, dA dt equals, and now we need to power rule, right? So we got 2 pi r. Whoa, 2 pi r. Oh my gosh. Wild, it's like the area and the circumference are connected. What? Times dr dt because of the chain rule. So then just for part A and for part B, we just need to plug in what we know. So we got A is, radius is 20 feet. So dc dt equals what? Yep, dc dt is 40 pi feet per minute. And dA dt is what? Yeah, we just plug in r. So we got 2 pi r, which is 20. And then dr dt is 50. Did I not multiply that right? No, I didn't. This is not 40. dc dt is 2 pi dr dt, which is 50. Okay, so then that's 100 pies, feet per minute. And then this one is 400. No, 2,000 pi. Feet squared per minute. Really? Wow, it's really big. No way. 40 times 50. No, it's 200. 200 pies. 200 pies. Wow, that was rough. So try B. Find the rate of change of the circumference and the rate of change of the area on your own. And hope that goes well. Let's put a question here. Yeah, so I think for part B, you should get that dc dt is going to give you the same thing, right? 100 pi feet per minute. And then dA dt is going to be different because that one depends on r as well. So that is 2 pi times 50, which is 100 times 50 again, so that's 5,000 pi feet squared per minute. All right. We have a 13-foot ladder, and that is leaning against a vertical wall. So we're going to draw a picture, right? We have a ladder. This is a ladder. And that's leaning against a vertical wall. And the end of the ladder is being pulled away at a rate of 2 feet per second. How fast is the top of the ladder coming down the wall when the top of the ladder is 12 feet above the ground and when the top of the ladder is 5 feet above the ground? And this is really nice because this is a 5, 12, 13 triangle. That's one of the Pythagorean triples. So that's really nice. So what do we know? We know that the length of the ladder, let's call this C, is 13 feet. The length of the ladder doesn't change though, right? So if we take this ladder, say this is a ladder, and then it's sliding down, that means that the length of this is not changing. So dc dt equals 0. So we do know that we have a squared plus b squared equals c squared, and that's our Pythagorean theorem because that's connecting all of our elements. So we also know that d, what do we want to call this? We have c, let's call this a and b for no particular reason. So dA dt, so this, the length on the bottom is actually increasing because the ladder is being pulled away from the wall. So that is increasing at a rate of 2 feet per second. How fast is the top of the ladder changing, coming down? So that's dB dt equals what? So we have a squared plus b squared equals c squared. When we take derivatives with respect to t, what do we get? 2a dA dt plus 2b dB dt equals 2c dc dt, and this is guaranteed going to be our derivative, implicit differentiation of our Pythagorean theorem every single time. And every single time we're going to have these 2's cancel out. So wise students, or lazy or efficient students, would just not write the 2's. It's totally fine. So for ladder problems, this dc dt is also going to be 0, right? So what we really have, what we're really working with is a dA dt equals b, negative b dB dt. And then I guess we just need to divide by b, so we got what, like a dA dt, when these are all numbers, over negative b equals dB dt. And then just plug in what we knew. Plug in what we know. So for part A, what do we get? For part A, we're working with the top of the ladder is 12 feet, so B is 12, and A equals 5 because we're working with a 5, 12, 13 triangle. So dB dt equals 5 times dA dt, which is 2, yes, 2, over negative b, which is 12. That's what, 5 over 6, negative with that. What's the units on that? Feet per second. Fourth choice in space. All right. And what about for part B? Try that. All right. So we got b. So we just flip our a and b. So b is 5 feet, so a is 12 feet. So dB dt is 12 times 2 over negative 5, negative 24, that looks like a 9, fifths feet per second. All right. I think we'll stop there. That is it's a long intro, but general idea. Draw a picture, write down what you know, differentiate with respect to time, plug in what you know, solve, check your units.